The first actual meeting of Great Thumb Silicon Valley. So welcome to Great Thumb and to SRI, and we are pleased to host you here. I think SRI is very enthusiastic to be involved in such an interest group.
I'm Bruce Damer, and this is our second meeting, but our first official meeting. The first one was at Extreme Pizza in the Mission in San Francisco. Who was there? Oh, it's a cohort.
We have proofs.
I was here
somewhere.
And just to give you a bit of background, Great Thumb is kind of like a society of artificial life practitioners that started in Boston, Cambridge, Massachusetts, really a couple of years ago. And I'm from two parallel worlds. I'm from the NASA world and stuff, research we do with Stanford. And it's my day job. But one of my other jobs is being part of Biota, the biota.org. I don't know if any of you have been to the Biota website. A few people. Biota was established 12 years ago as a new community resource for artificial life, which included a lot of the original practitioners like Carl Sims and Tom Ray, and included some really cool people like Richard Dawkins and Douglas Adams, and science fiction writers like Rudy Recker and Bruce Sterling, and really interesting organization. And we held 4 conferences. And then 2 years ago, about the same time the Great Thumb groups were starting, we started our podcast. And those two things sort of have converged together. And so what we realized we had a natural partnership. The Great Thumb clubs were kind of like homebrew computer clubs. In fact, the homebrew club inspired the one in Boston. And the homebrewing, why is it? A Great Thumb will think green thumb gardener, Great Thumb gardeners of technology. We had a dialogue with them for about a year, and then I went out there in March and went to a meeting, did a talk at a meeting on a project that I'm trying to get going within the A-Life community called the EvoGrid. And I'll talk more about that later. And it was a really good chemistry and good group of guys, and mostly guys, almost old guys this time too. See, women can already make life, and they go like, why are you people, why do you care? So we can't, so we're trying to do it this way. We can't procreate. We're trying to make sure we're not going to be made redundant in the future. So what happened out of that was the EvoGrid idea got really widely circulated and supported, and they supported the idea of starting a Great Thumb Silicon Valley Bay Area. It really isn't strictly Silicon Valley, it's also Bay Area. And the Great Thumb London. And so both of these groups have now gotten started. I'm going to the London one in July to help sort of spread the word and whatnot. But so what Great Thumb is like a homebrew computer club for people doing A-Life, which means part of it is show what you've done. They met in like really noisy bars and pubs for the first year, and in their houses and stuff. And they only went to the presentations format later on. And they're the Bostonians, and they're sort of regretting that and sort of push back to the over-the-bar napkin drawing of the architecture. They're kind of going back to that a little bit more. So their advice to us is like, stay non-commercial, no product pitches, all that, and try to at least do some conversation over beer and good pizza and napkins and stuff like that, and make it a working group rather than just sort of a presentations group. But every week, for our first meeting, our first informal meeting, Jeffrey Ventrella came and showed Gene Pool. And how many of you have played with Gene Pool? It's really great. It's one of the classic. He's going to open source it, at least he said at the meeting. And then we were thinking of looking at ways to get gene pool into a 3D environment and update it and put more physics in it and do all kinds of cool things with it. And then somebody else put their hand up and said, I'd work on that. So that's exactly the kind of, and we have an open source platform we built for NASA that I want to use for that. And I'll show that after you're done. I'll show a few things. The last thing is that the EvoGrid idea, and I'll talk more about it later, as you're looking at A-life environments, one thing that jumps out is how specialized and customized they are. You know, they're customized to show a certain property, or L-system forests, or physics-based evolvers for walkers, stuff like that, ant colonies, swimmers, things like that. Think of, in the modern age, when you have massive multiplayer online games, it's all grids. Think of, what if your environment could be encapsulated in XML, described to the outside world, and everything in it, the creatures and the plants and the properties encapsulated somehow, and that you could transmit your critters or objects over the net into somebody else's A-life environment, and they could send stuff back to yours, and you'd be part of a grid. And of course, your swimmers would arrive in the dry land world and flap around and die over time because they didn't have the affordances, but that's so be it. You know, that's the way it is in nature too. So I mean, the EvoGrid idea is simply that, is to create an evolution grid. EvoGrid.org is, we got the domain, it's pretty cool. But an evolution grid so that the sum total of all A-life systems can start growing a lot faster. The adaptive properties can be observed quicker, and projects that die when you run out of time and energy can be picked up by somebody else. Or your A-life environment will continue to run in the grid. Until somebody says, there hasn't been code on this for 6 months, what's going on? But it's still usable. It's a citizen of the grid and things are going on, going in and out. And other person picks it up and keeps evolving it. So that our field, which has been chronic suffering of fossilization, where Carl Sims creatures are only visible in an MPEG file because they're a fossil, because not only did the code die, but the machine it ran on died too, you know, the connection machine. So no more fossilization, like no fossilization t-shirts. Anyway, that's my spiel at the beginning, but I want to introduce, you're going to have to introduce yourself.
Hey, I'm Chris Duffield.
Why don't you just plug it in here?
I hang out at Stanford, mostly at the medical school, but all over campus. And I don't know, Bruce dragged me in here. I thought it'd be really fun.
You teach or anything?
Just research, and mostly go to seminars and come up with ideas and give them away.
Yes, I'm Steve Gans. I have a background in programming languages, but a lot of interest in AI. I'm working for Blue Vector Systems, Snap, small company in Palo Alto.
Yeah, Osher, I'm from SRI and work here at the lab. I work on large-scale multi-agent systems. That's it.
My name is Shai, and I'm a postdoc at Stanford. I'm a computational biologist, and I've done some work in evolution, some work on gene networks, currently doing stuff related to translational bioinformatics, linking clinical data with gene expression and so forth in the domain of immunology.
I'm Ashish. I work in the computer science lab here at SRI. My broad area is system securities. Not quite the same interest as you. So interesting.
He's from the security.
My name is John. I work here at SRI too. I'm generally interested in machine learning, but my work's more security related.
My name is Ophir. I'm a postdoc at Stanford, and probably the only one who is not computational or programming here. I do immunology, and always have done life sciences stuff. So for me, it's interesting to see what this is all about, and maybe pitch in an idea out of the scope of programming languages.
Great.
Hey, Andrew Clovis, work in the Cognitive Innovations Lab, and I design robots for the Mars Society.
I'm Scott Davis. I'm a computer programmer, work at Nuance Communications. My connection with artificial life, I work on an open source social simulation called the Mars Simulation Project. And been working on that for years, but that's all I do.
I'm Jim Brown, very active in the Mars Society. I've helped him with some of the technical stuff, but I haven't really done any coding. But I'm interested in artificial intelligence and a lot of things.
I'm Allan Lundell. I'm a journalist and filmmaker. I have a background in, as well in medicine and experimental psychology. I worked with a professor who had worked a lot with Wilhelm Reich, who was interested in origin of life research, and I know a lot about that and how that kind of biological explorations of life might interface with the computer world. In the computer world, I was the first West Coast editor of Byte magazine, and then InfoWorld, one of the founding editors of InfoWorld. So I've tracked what's been going on in this valley for a long time.
Including Homebrew Club.
Turn
Yeah.
be on camera.
Don't forget to be on camera. I'm attracted to seminal events, which I consider this to be, and I'm pleasure to meet you all, and look forward to hearing your stories.
Bruce Damer, and I founded the biota.org organization in 1996, which is a part of this effort, and helped start the medium of avatars in the mid-90s, and wrote some of the first graphical interfaces on PCs in the 80s with Xerox. And in the 2000s, I've been doing mission simulation for NASA for different parts of the agency. This, you might hear Popular Science subscribers, that's one of the pieces we did last year about how to send people to land and explore asteroids with a human crewed mission.
Yeah.
So our team does all kinds of real-time physics simulations of mission scenarios, and it's all open source, and I've been building this platform. We have 6 full-time people on this in order to create an environment for artificial life. So Python is in there, everything's in there you'd want, ODE, stuff like that. So one of my missions is to give this away to this community so that we can have a good, solid framework for our work. So we have one framework instead of 20 frameworks, if it works. And my current effort is called the EvoGrid, which is to inspire the community to create a grid of artificial life environments where they're all communicating. And that's actually part of PhD work I'm doing in the UK. So it's all blended together in a diabolical way. And then we're going to go back to NASA, get more funding to do evolving robotics, and it'll all just cycle back and forth in some way. And then suddenly the robotics will appear in Second Life, and who knows what'll happen.
I'm Scott Schafer. I really consider myself a hobbyist in artificial life. This isn't my job. But something I've been playing with on and off for a couple of years now. And it's great to meet freaks like me. I'll admit I'm a little intimidated by presenting what I've been working on, because I feel like I'm coming out of the cold a little bit. And I'm just really impressed with what I've seen, and hope to instigate some collaboration.
So is this your project we're about to look at?
Yeah.
Wait, turn up the... Up is off.
Up is off. This is the government.
So, I thought I'd begin by just showing version 1.0 of this project, just giving a quick demonstration. Basically, it's a very simple environment. It's not a true physics simulation in any sense of the word. Basically, it's a 256 square grid of pixels. The green dots are food, and you can magnify the center area. And then basically, in this version 1.0, a critter is a series of instructions. Each instruction corresponds to a segment. So the simplest critter would be a move instruction. And actually, they evolve very quickly. Let's do that again. I'll turn this, okay, so the speed's way down here. Mutation rate's off. So if I insert a single critter, the there they go. When they hit the green dots, they eat, gain energy. When they gain enough energy, they may reproduce, produce a copy, and with mutation enabled, they can either gain an instruction at random, lose an instruction at random, or have one randomly changed. And so crank it up, and the world wraps around, so they go to the left, they end up on the right, vice versa.
What's the rate of food production?
Well, okay, so the way the food works is, periodically food is put out at random, and the more food that's out already, the more food is generated. So it's essentially like plant life.
It's like there's flocks of them sweeping away the food now.
Yeah.
Right, like
Yeah,
invasion waves or something.
They synchronize, don't they? They like move in waves.
Yeah.
Instead of moving from bottom up. And
Yeah. It's very
Is
interesting.
there a pheromone system?
There's not. What there are, some of these instructions, so this less than symbol corresponds to rotate 90 degrees to the left. I should say that each of these is sort of like a worm. You can see one moving right here. They have a head which can be oriented in 190 degrees. And so the turn instructions rotate the head. So you can either turn left or orient in a specific direction. So you can orient up, or you can turn 90 degrees to the left.
Do they collide with one another?
They do, and so there are a few conditional instructions, and one of them is if blocked, blah blah blah. So they can't go over each other. They can't go over themselves.
How far ahead can they see?
I think it's set to 16 pixels right now.
So they hunt for food, or?
Yeah, basically they're hunting for these green dots, which are put out at random. So they have different strategies. Some of them will like sit in one spot and spin around and look for food. Others will be more active.
There was a period where the green dots suddenly increases, where a population crash, because they're like die-offs, overpopulation, overconsumption of food, and they die off.
That's what seems to happen.
Do these die off if they don't get food for a while?
Exactly. Yeah. So they lose energy every turn.
Any surprising observations so far?
That's a good question.
No sex involved.
There's no sex. It's
So
it's G-rated. There have been a lot of behaviors that evolved that just surprised me, and I wasn't expecting that, and that's always fun. This is kind of a cool thing. I have it set up so that if you click, oh, maybe not. Oh, there you go. So the insert barriers button puts out these white barriers, and they can't cross them. And these guys, very well, they can't see through them either. And you know what? I think I just killed them all off. One thing is that it seems that when they get more adapted to their environment, they have a harder time to adapting to changes. So a sudden change, after it's run a while, is going to be more catastrophic if I change it.
Yeah.
You're looking at the future, folks. After humans go extinct, the Earth's going to go green again.
Exactly.
The redwoods will come back.
The redwoods will
Talk
come back.
about graphing the results. For example, in GenePool, they have the graph where you can see the population of critters versus the food, and you can see kind of this wave of them going back and forth as they get better, evolve towards their conditions. It gets closer and closer over time. I was wondering if you had thought about doing something like that, a graphing system of the results.
Yeah. At one point, I had it spinning out a text file, basically CSV, so you can graph it. I don't have that now. I do have there's a tally that basically shows different populations. And by the way, each sequence of instructions is assigned a color. It's kind of considered a species.
Can you move that lens around in the center? That's kind of a magnified view.
No, can't really. So right, this is version 1. And
What was your inspiration for
it? I was in a relationship that wasn't going anywhere.
It's like Burning Man came out of that.
Actually, what really did, but actually reading the book Chaos There was a section where he talked, originally, so there was a section where he talked about the relationship between predator and prey and how that was a chaotic cycle.
Yeah.
And so originally I just set out to simulate that, just out of my own curiosity. And then I thought, what if I added this, and so on.
Is this a downloadable program? Is it open source? Is it available on the internet?
So the program, I mean, there's no reason why it couldn't be open source. I can share it with you. Both of these are, Windows programs written in MFC. Not the most portable, but hey.
I noticed that that they were the strings were getting more complicated until you put up the barriers, and then it killed off all but the very simple ones.
It's true. I mean, they do evolve back, and they become more complicated again over time, and more capable.
Is it just a single worm-like line, or do they produce other structures, or?
Yeah, it's a simple line.
Just a worm.
Yeah, I've wanted to come up with some way to have them have offshoots and whatnot, but I think at that point it would have to become particle-based and kind of more of the physics environment. So, and basically, I mean, my goal with this, I'm interested in the Carl Sims stuff blows me away. You know, I like that a lot, but my goal for this was to really kind of focus on the instruction set. So.
Yes, what is the instruction set? And does the sequence of instructions automatically repeat over and over?
It does. Actually, let me try to pull that up.
Yeah.
Now you said that there's no, they don't have sex in it, but how is reproduction done? Is it after it gets so much food they will do reproduction?
Explode.
Asexual. Yeah. So basically, yeah. There's a threshold. There's a formula. Basically, the number of segments they have determines the energy they need to divide.
Okay.
And so once they gain more energy than that, they produce a copy or a mutation.
Attack.
Yeah. The attack. Okay. So the attack doesn't really work very well in here.
You don't.
Part of the thing with I couldn't quite figure out how to make them attack each other, and I figured it out in Critters 2.0. I have a implementation which we can look at.
The energy of.
Well, there's no way to boost the resolution of the projector, is there? Does anyone know? I'm just realizing we got some controls off the screen here.
Boost the resolution.
Might be able to read. Yeah, you can do it in your Windows. So.
Okay.
Display options.
What about social interaction? I never see social interaction in terms of cooperation.
They do those waves going across things.
Yeah, but
they're synchronized.
I think it's a function of how the abundance of food, because they tend to eat off, right, and then they kind of synchronize how they eat off the food, and
they all get
whatever's left is in front of
it.
it.
If they're in the same species, have the same instruction set.
Yeah, or close.
They're all moving at about the same speed, so it would be.
But since they're affecting their environment, they are in a way working as a community to do it, and they're interacting through their environment.
So, that's an interesting point. I mean, when you look at the community, they appear to behave uniformly, but they do not cooperate as individuals, so they're not really a community that communicates with each other.
No,
well, they're communicating by food from the other ones can't get.
Right, but it's an emergent behavior the way it's built in.
Each other. Then they could protect their area.
Well,
they can blow.
Yeah, he has
So shall we look at the version 2.0? Let's talk about it. It'll answer some of these questions. Whoa.
But you can't very well protect your area if you can't somehow keep others away.
You can.
Yeah, right. Well, he has an attack instruction.
Well,
yeah, they can't attack each other, but they can block.
Yeah,
one can
always block. Right.
Yeah.
Interesting.
I'm sorry, while we were talking, Windows reverted my display settings, so.
Whenever I see something like a little worm-type simulation, like this, it always makes me think of Tron. The little motorcycles out there.
Yeah. I was on the set of Tron.
Were you?
Yeah, it was
You were on the
a set of Tron. It was primitive computer graphics at the time.
They remade it.
Yeah.
It would lose
Yeah.
so much. If they did.
Yeah.
Yeah.
Plus, Jeff Brady.
You might have to.
Riding that bike.
So probably
Maybe 5 years ago or so.
So
Some minor updates.
what 2 was your want to take it to the next level? What were you trying to do with 2?
You know, I got inspired just by seeing some work other people had done and some conversations, some arguments with creationists. Have inspired me to read it. Yeah.
So you added some additional control over food issues that we were talking about?
Yeah, well, so basically the solution I came up with was, and
that's pretty sick.
it's really sick.
It's not fast. Huh?
Let me write it on Bruce's machine.
Mr. Ready. Oh,
Yeah, you're gonna have
it's
to
toast.
force quit control panel.
Critters 2. So, yeah, so, or a Micropond, like, you know, I developed Critters before discovering Nanopond, and that was kind of interesting to me. See, somebody else had tackled similar things. This seemed a little bit more macro, maybe one step up, because these critters have more than one segment, whereas in Nanopond they're really just one pixel with many instruction sets. So okay, so I had a problem with the attack. You know, how to make one critter attacking another. How to have that make sense, because just colliding doesn't really count as, you know, what. Initially that's how I had it. I had an attack instruction, so one critter could attack another, gain energy, but it was just too simplistic. And, you know, sort of what happened was all the critters just ended up with attack instructions, and that was it. There was no need or even possibility of developing any strategy beyond that. So the other thing I didn't like about Critters 1 is there was a distinction between the food and the critters, and the food didn't evolve. The critters did. And I thought, well, wouldn't it be nice if the critters were food, and then they can drive their own evolution? And so basically what I came up with is, in Critters 2, there's a segment which is the photosynthesis segment. And so a critter can have a photosynthesis segment, but that segment is vulnerable to attack. So, so at the top, these are critters that I handcrafted, which basically if we crank up the speed, basically what they do is they curl around. The green is the photosynthesis segment.
Yeah.
So, and then below, so this is a multi-threaded environment. Each world is its own thread. And then there's actually a third thread which just creates the UI and this little snapshot here. So, oh yeah, we can move the snapshot around just by clicking here. And we can, it gives us a look at the individual critters. The white bar at the end is the energy, and the arrow shows the direction of the head if the critter contains a move instruction, which these guys do, but they just to move into their configuration.
Can they identify the state that another critter is in?
They cannot. Well, except to say that another part of the design was to make the sort of virtual machine kind of more plug and play. And I haven't quite worked that out, but basically the idea is that you can create a new virtual machine with it. That a critter has basically a series of instructions, a buffer that controls its behavior, and that the virtual machine gets to decide how to interpret that. And basically there's an area that's the data area, which is variable. The virtual machine can say, okay, I just need a program counter, so I just need one integer for the program counter. But another virtual machine could say, okay, each critter is multi-threaded, so I'm going to have 3 program counters. So right now it's kind of limited, but hopefully that's beside the point.
So what are the red and blue sections in some of the critters?
Right. So okay. So with this particular virtual machine, basically the way it works is you get a series of instructions, and some instructions map to segments, others don't. So the the yellow is a no-op that is also a segment. And the red is a...
Oh, what happened?
where are we? Oh, down here. Yeah, we just had a more intelligent critter evolve, obviously.
Oh, man.
What happens here is kind of interesting too, is that, you know, I handcrafted these critters. Well, I'm going to crank up the speed and let it go.
These are two worlds operating separately?
Yeah, exactly.
The upper world and the lower world. Huh?
Right. Well, so these are the critters. You can see this guy that, you know, I designed this with my hand, just to kind of, I had an inkling that this would be sort of the omega critter in this environment. They're a critter that would just be invulnerable to attack. It could generate its own food.
So it's basically defensive and then generates its own food, protecting itself.
Right.
Yeah.
Right. You know, a critter, so basically it gains energy each turn depending upon the number of photosynthesis instructions it has, or if another critter moves onto a green photosynthesis segment, it eats it, gains this energy.
So is the best strategy in upper world to eat your own generated food? Is that the fastest way you can gain energy?
Well, so these guys, they're not carnivorous, and you can see that because you know the red move segment. You need the red movement segment to be carnivorous. That indicates move and eat if you hit a green dot.
So the ones at the top are like a field of grass, basically.
Basically, yeah. So what happens? It's kind of interesting. If you give this long enough time, what will happen is this surprised me a bit, that the perfect critters kind of devolve over time, because I mean they have a lot of segments. They've got it makes sense when you think about it, but they don't have any predators, and so it's sort of like the dodo bird, which was its ancestor was a pigeon, and it flew to this little island, and it didn't need its wings anymore. And so basically what happens is some of these, okay, so we have some predators here, and you can see by the red dots. And they're finding something to eat, so...
So you created the initial creatures. Those are designed. And
Yeah.
then these ones with red in them have evolved from that.
Exactly.
Will there be a sudden phase transition and crash in the population as the predators grow and take over? Or?
You know, it seems like what happens with the upper segment is basically over time the sort of perfectly defended critters devolve because they don't have predators eating them. And so it's more efficient for them just to have more photosynthesis segments and so on. And then, okay, so right here we see some guys eating the mutations. You know, you'll still see some of the original critters hanging around. And down below, it takes longer for interesting things to happen. I think if we give this enough time, we'll see some critters that have a similar segment, a similar strategy to these guys, where they're kind of hanging out and either individually protecting their photosynthesis segments or kind of forming a colony.
That's the emergent behavior.
Yeah, in the colony, then you're... Yeah.
So what's the square on the bottom?
Oh, right. Okay, so there's actually two kind of special territories that I threw in just for fun. This is, the gray dots are barriers. So it's an area where the critters can't move freely. If they hit a barrier, they either have to turn or they'll just stop. And then the center area, no photosynthesis takes place in there. So if you have a photosynthesis instruction, you get no energy.
And every once in a while I see a computer moves from
Cross, yeah.
Yeah, crosses that middle area.
Yeah.
For long.
What?
But some of them die halfway across.
It's a good question why they're doing that. I mean, it's
Get to the other side.
yeah. Who knows? I really I'm very mystified by a lot of what they do, and a lot of behaviors I expect to see happen just don't.
It's turning into Swiss cheese up there, really.
Yeah.
Emergent behavior.
Those golden wings.
Really cool.
So
Is there any energy expenditure in this?
there is. So there's there's a certain amount of energy expended per turn. There's some amount expended per move. Consider that a special instruction. And that's pretty much it. And then different instructions, it's all a little arbitrary, but they take different cycle times.
Does turning cost more energy than going straight?
It doesn't right now. I mean, turning and moving are separate instructions. So, but you know, that's a lot of these are parameters that are somewhat exposed, and I hope you'd be able to toy with and see what you get.
If turning and moving are separate, I'm sorry.
Yeah.
If they're separate instructions, in many ways they do cost. They cost more energy because it would take you, one step to turn and then to move some direction.
Because it's true, but you might turn and not move. So if you're like looking for food, for example, you might just turn, look for food, you don't see it, turn again.
And you don't take it, you don't lose you don't lose energy when you're just turning?
Well, you lose energy every time you take, well, yeah, terminology is challenging here. I mean, every time a critter has some cycles allotted to it. That's sort of a turn.
But when you actually move, you use like two units, and if you're not moving, if you just turn, you stay there, it's 1 unit kind of a thing?
Something like that, yeah.
Hunting food, do you go after the closest food that you see, or what exactly?
Yeah, well,
or do you?
I mean, different critters just evolve different strategies. So
Okay.
I'm not sure how to answer that. This particular instruction set, by the way, is I've been playing around just to see what works better, and originally the first one, Critters 1.0, was much more. It was a very standard instruction set, so it was kind of your if, then, do this, else. This particular instruction set, basically every instruction is an integer, and there are some bits within it that say execute this instruction if these conditions are met. So it's like every instruction is an if statement, which, it's not a language. I mean, that's one thing that really interests me is this idea that I have this intuition that the ideal evolvable instruction set is not going to be human readable. I could be wrong, but I mean, my intuition says like the ideal one, the one that's going to evolve, is not going to be one that humans would want to program in. I don't know why I feel that way, but I mean, does anyone else?
What do each of the colors mean?
Oh, the color. Well, basically, so as I said, each critter is a series of instructions, and some of the instructions map to segments in this model. So a move. Well, there's two kinds of move. There's a move that will eat, and that's the deep red. And then there's a move that won't eat, that will just stop if it's blocked, and that uses half the energy. And then green again is photosynthesize. Blue is sleep. Oh, so down here we're seeing some colonies that are kind of forming. Oh. So check this guy out. So this is basically a variation of the critter that I hand-coded up here. It's a little longer and it's using moves and not no-ops, but.
So were you saying that
It's head against itself.
were you saying that the instruction set itself evolves, not just individual programs?
Well, when you say the instruction set evolves,
I thought you said before you were surprised that, you were thinking that the instruction set that evolved wouldn't be something a person could read. You mean the programs wouldn't be ones people would?
well, yeah. So for this particular, I mean, you can think of this as more of a machine language than a programming language. I mean, I'm not sure. I don't think that distinction is really valid in this kind of project because, when you're writing a programming language, you're writing for readability, maintainability, and there's no one reading the code here. It's just haven't shown yet.
There's no way in which they could leverage off of abstractions of things that had worked in one context and recreate a whole block of themselves.
You mean like a kind of a subroutine?
Yeah.
Kind of a design pattern?
Mm-hmm.
I'd really like to see that.
Mm-hmm.
And that might be Critters 3.
Do they die of old age?
They do.
So even if you have a colony where they're completely defended, eventually they'll die, or
Yeah.
one of them
Enough of them will die so that
make room.
It's true.
Do they know that they're aging? Like, does it affect their behavior? Or does it come out of the blue?
Sudden death.
You know, I mean, there is an instruction in there that's like a decrement and branch kind of thing, and
do they,
potentially, I'm not sure. I mean, you kind of have to get in there and see what's going on.
now when they reproduce, does it make two identical or nearly identical? And does the age reset to 0 when that happens, or does one keep the old age and the other one keep it to start off a new age? So is one clearly a descendant and the other one the parent?
So are they budding or dividing?
Are they truly splitting?
Right,
And both of them starting off with a 0, or is one keeping the age and the other one
That one.
zeroing?
Yeah.
So one is constantly getting older, so the new ones are gonna, so the old ones are gonna die off,
Right.
and the new ones,
Yeah. I mean, basically, yeah. When what happens is they reach an energy threshold, they divide. If mutation is off, you'll get an exact copy. And then, but yeah, the one that was aging, the old one maintains its same lifespan, and the new one gets a new lifespan.
And the new one would be able to mutate, where the
Right.
old one would not.
Exactly.
If you have mutated, so.
And
so you kill off the non-mutating ones.
yeah, you know, I've just played with a lot of different factors here. One of them is I think about you know, we all have genders, right? We're all, you know, there are some sort of random factors. You don't consider it a mutation if somebody's born a boy or a girl, and yet there is that kind of variation that happens within a species. Or,
But there's
Yeah.
the fluke,
right, but there's also like so.
which they're neither. It's neither. They both can be either, and it's the strongest one basically is the male, and the weaker one is the female. So the weaker one has to produce the baby.
Well, I don't think my wife would agree.
In flukes.
Yeah. Oh, in flukes. Oh, okay.
Yeah.
One more?
Well,
Can we get it from that side too?
Yes, it's a fluke.
It's hypnotizing.
A fluke
What's
is,
the longest you've run it?
nature.
you know, I get kind of. It's hard for me to let the whole thing run because, you know, a few hours into it, I think, oh, what if I made this change?
You can run it overnight, so
Yeah.
in the morning.
I'm a little concerned about this sort of the omega critter problem, which is, you know, that there might be sort of within the simulation there might be just kind of a simple solution that nothing else can really compete against, and it might have to do more with sort of how the simulation is set up than the intelligence of the critters or the instruction set. And so I'm not really sure how to gauge that. You know, I mean, ideally I'd like the kind of the simulation to be complex enough so that the evolution could keep getting driven forward. And I'm not sure this is it, and I'm not sure how I'd know.
You might want to try putting more complexity into the environment itself. Perhaps changing sets of obstacles, or perhaps obstacles somehow produced by the organisms themselves. Much like a sea creature might, you know, create a shell or create coral or something like that that change the landscape.
But you could make that so that
And you
it
might also
slowly
want to mix the randomly
burn away too.
distributed food with the organisms that can eat each other. So you get some that specialize in eating this randomly distributed food, whereas others specialize more as being predators. There's a lot of different possibilities. And of course, always increasing your instruction set to offer more ideas. Also, the ability to sense further could be a...
I'm sorry, to what?
To sense further
sense.
around
But
the
it might cost more energy.
there might
to
be
do it.
a cost associated with it. I mean, just some things off the top of my head. I had talked with Jeffrey Ventrella about his gene pool program with some different ideas that he might want to use. And I can see a lot of them could also be useful in this.
Maybe I should put up, because I've got gene programs here. If you want to-
Why the squares? Why do they form the squares on the
Drought.
Is
Square in
that,
the middle is
In the center?
Yeah, in the
because
center.
there's no light there.
No light?
That's a
Yeah.
shadow. There's no light there,
So you could actually make a gradient.
so there's
like-
no food produced there.
Oh, okay.
So,
No food in the center.
so
So
you
the
could even have like
photosynthesis is more effective towards the bottom.
Yeah, something
Yeah.
like
Maybe a
that.
circle then?
or
Huh?
here's
Something
another
about a
possibility.
circle?
You could have
It's just
multiple
the
layers.
it's
to
a
simulation,
rectangle
much like
shadow.
layers in the canopy of a jungle, whereas the top one might block off light to the next one, and so forth. And you might have critters that could actually pass between the different layers.
Interesting. Yeah. It'd be fun to make that more kind of an interactive process where you could do a shadow square.
One other direction that I would think about, trying to think this is just analyzing the data that you're generating. And you can imagine trying to quantify different critter states and seeing how you transition between them and so forth. Because right now it's a visual environment, and you're a lot of what you're getting is from zeroing in on a particular point. But it'd actually be interesting to see what happens on different scales and so forth, which are probably going to need some analysis.
Have you considered using sound as an indicator of change?
Thought about it.
Yeah.
Do you have any ideas?
Well, I was thinking that when you reach a certain critical change, it would give you a sound effect that would let you know that was going on, some kind of mitosis.
Maybe like one sound for division, one sound for eating.
Yeah.
Photosynthesizing.
Well, you're talking about just in the user interface?
Yeah.
Or
Well, to
something the critters
listen
can
to the
recognize?
critters as they're to
Yeah.
represent the behaviors of the critters in terms of
Oh, I see.
acoustic.
Yeah.
But these are such big spaces with so many critters.
Well, it'd be like Brownian sounds or crickets, maybe,
Yeah.
like crickets, where you could.
Right, but you might also have ways in which the critters could have access to what's happening around them through, it doesn't matter if you consider it to be sounds within the environment or smells or whatever, but maybe anytime something happens, it could be a field around it that gets stronger in the center and weaker as it moves out.
In 1.1, was it, you showed some of the different codes that different genes basically that they had, but in this one you don't show those.
Yeah, I don't.
Probably have so many different critters in this one.
Yeah, that was part of it. At one point, I tried to kind of sample the instruction sets, and I mean, the longer the instruction set gets, the more differences you have. Like the harder it is to. When you only have like 3 or 4 instruction sets, it's easy to say this is a species, this is a species.
Does each instruction set cost energy
To
maintain?
It doesn't. It uses cycles. So basically, every turn, when I say, execute instructions, you critter execute your instructions. Here's how many cycles you get, and then every instruction uses a certain amount of cycles, and additionally, some instructions like, move costs energy. So none of the others do.
When they prey upon other organisms, is it any part of the critter, if it touches the green part of another critter?
Yeah.
You might want to consider a part of the critter that is a weapon or some kind of something that it can prey with. And just like you have the green ones that are the only ones that can be eaten, perhaps this other thing is the only thing that can attack, can prey upon the others. Maybe it'll tend to be towards the front, or maybe it'll be on the side and it just happens to brush up against the green one. But that might be a evolutionary, might produce some interesting effects.
Before we run out of time, so I'm not sure when our stopping time is, but I've got 3 more ALAR systems to show you guys from other people to get you thinking. How do we go to?
Well, thanks very much. That was very cool.
A project 10 years ago called Nerve Garden, which used Lindenmayer systems. Anybody know what L systems are? They're sort of rewriting rules that allow you to make beautiful branching structures that look like plants and insects and things like that are branched. And that was done in Vermal back in the JavaScript Vermal days. And the vision that we always had was to do a real growth, plant growing system. And this is actually a team in the University of Paris that actually has done, oops, there's a display problem, into the soil. And you can see that the roots are actually hitting where there's minerals and, oh boy, I tell you. Anyway, I'll just keep it static. It's a display. This is all done in ODE, using ODE and Ogre. So you can actually grow whole forests and have the plants shade each other out. And there's quite a few papers been published about this. But this is sort of grass growing, and there's a tree in the background, and things are fruiting and whatnot. Beyond that, one of the problems, of course, in all of these polygonal-based rendering systems is you reach a point where you're getting down to 1 frame a minute and that kind of thing. And that's always a chronic problem. But Darwin's Park is really cool, and I can't do it justice just in a second showing you, but perhaps in a future, Gray Thumb will get better training from the people at the University of Paris and give you a more full demo, or we'll pipe those guys in. But this is actually being used to do agricultural yield studies in the European Union now, where they're actually creating. Yeah, it's just excellent work. It's at the Artificial Life Lab in Paris.
What's the energy input? The solar water?
Nutrients in the soil. Photon. There's a photon model in it, and there's shading, and it's necessarily simple, but they've done statistical. Sun and soil. And shadowing, and they can show the phototropism of plants and things like that.
So what parameters are they trying to control for in the study?
In different configurations.
So how far apart plants are forced to be from each other?
How far apart they are, the structures interact or collide, and shading of larger plants on smaller plants. But there's numerous papers on that. And certainly if you email me, I can connect you with the resources. But this is actually sort of a view of these are the Noble Apes moving along in the landscapes and interacting, and then this is the actual neural net brain structure that's going on as this particular ape here is moving around and detecting its environment. And this is done by Tom Barbalet, who also runs the Biota podcast and the website.
Very good podcast.
The Friday night thing, right?
Yeah, and there's on Friday nights there's a live call-in show. Friday nights and Saturday morning is really good. It's really good. And there's a call-in show that's recorded. You just phone in and it's recorded for real time.
And if you're the only one who calls in, you get interviewed for the whole hour.
That's right.
Happened to you, did it?
So find all of Tom's work at biota.org. But this system, and this system's a real pathfinder, even though it's sort of mid-90s graphics. It's a tremendous pathfinder for several reasons. Intel and Apple both use it to test their microprocessor architectures.
What?
So there's versions of Noble Ape running on vast multi-core processor die things at Intel, because it's so well threaded that it just uses up. It'll drive all the CPUs, and So it's an industrial. It's become an industrial application.
So meaning you just make a bigger world with more
Bigger
apes?
world with more apes than they will use up, and there's a lot of statistical output, so they can characterize the performance and the threading and everything. So really, just tremendous.
So what's each dot, black dot there on the...
That's sort of the ape brain. That's
So what does it mean?
That I wish I knew. I've got to read. There's the Noble Ape book. If you email Tom, he'll send you the book. It's this funny little white book. It's about Noble Ape, and it has everything. And I really have to read it and really understand. But I think this is like the crossbar in the neural net in the brains.
Actually, Tom wrote me to say that it's not a neural net.
It's not a neural
It's
net.
often characterized as one.
Oh, okay.
Yeah, but he didn't say what it was. It's a cube of some kind.
It's a cube that's
It's a
characterized.
three-dimensional.
So it's basically what one of the ape senses.
Yeah, and I think there's a way to get at another ape somehow. But
Can you pause the thing?
Well, I wish Tom was here.
This
His
is like
controls are up.
Windows 95 or something.
Well, it's just as with many of these simulations, it's focused on just I don't know how to do it. Oh, there we go.
Next day.
Oh,
Okay, now
Under
we have,
control.
there.
so now can we switch apes?
Here's the cube. And let's do it
Yeah, under control.
next ape. Okay, there we go.
Yeah. Doing anything?
Okay, now we can
I
resume.
wonder what those white marks are.
Boot.
And this is like Second Life's Islands. It looks like archipelago of land. So nobleape.com, and if you want to reach Tom, he's Tom at nobleape.com. And you can get a t-shirt. There's actual Noble Ape t-shirts that are very cool. So that, you heard gene pool mentioned a lot. This is a gene pool beta 6, and it's pretty stable. This only crashed on me once, but this is, Jeffrey Ventrella shows his real stripes as a very good artist and game developer because his creatures are so alluring.
Yeah.
And this was developed, I think, about 10 years ago now. I think it was developed at Rocket Science Games, and then he was able to continue it.
Huh.
But this is what he's talking about, open sourcing and going into a 3D environment. And I'll talk to you about that in a minute.
I found this beta version 6 ends up producing more interesting, more complex creatures, or swim bots as they call them, than the previous version. The previous one was more polished. This one isn't, finished yet.
Yeah.
But it tended to stabilize with the very kind of common structures for the swim bots, and this one I think produces much more interesting ones than the previous one did.
Are there different environments within this ocean?
I don't
Just
think
basically
so. I
uniform?
think there's just food. You can move them around, these guys around, and you can point at food.
Yeah. They basically compete with each other for the food, which are those green dots,
Mhm.
and then they mate with each other.
What's the initial state that the system starts in? Or the
It
systems
starts with a random genetic set of these swim bots with random structures.
So they're
to a certain degree.
functional.
And
They're
then
not
a pile
these are
of
for
food in
them
the
all.
middle. What's that? Yeah, they are functional, but you don't know. I mean, it doesn't necessarily mean that they can swim very well.
We're going to
In
make
fact,
some
many of them can't,
identical
they just end
twins.
up dying of
Oh,
starvation
they
or
died
old
off.
age after.
Clone
But the ones who are successful, even
Oh,
if
that's
they're
a very
really
small
slow, will eventually
They spat out
when
clones.
they get over a certain threshold of food, they can find
Let's
another to
clone
mate.
this one.
And then eventually their genes will get passed on enough that
So what's in the
swim
engineer?
better and faster.
Sorry?
What happens if you click on engineer?
Will really
that's
start
like a
taking over.
gene editor.
In fact, once you see a
Oh.
really successful one, it'll be like a virus that will shoot through.
And can they mate with any other species?
They can, but they have
But they may
preferences.
lose the characteristics.
Well, they have preferences of what they like to mate with.
So that's
When
another
they
big
basically
slide
would
or
see so far around
growth
them,
turn
and
amplitude.
they
Okay,
would
so
pick
it's
the one that they find most preferential. And And you can set what
That
you
normally was the one that's most like it.
Fractal.
by default
the
it is
fractal,
basically
like the bow plan.
similar colors.
That one's dying.
similar
See this
structures,
one?
something like
They,
that.
they
But you can
start
set
to
the parameters
die.
to be complete opposite
See
or
that one there is dying. So there's a nice visual
short ones,
cue.
long ones.
This one's
The
about to.
colors get browner.
Fun.
Yeah, this is
And when-
about
when
to
they
die.
change
It's
genes,
gone,
how
but
do
it
they
doesn't
do
become energy or food.
It finds the average between the two and
But
that's
here's a whole bunch of
no
clone
matter
ones that I
random.
made that are sort
So
of
for all the
competing.
genes that make it up, that define the structure, it's movement.
So they're going for the
kind of
green dots?
signs
They're
of
going for the
movement.
green dots.
It's a very simple water
What's the
model.
name of the game? It
And,
was, they demoed it.
so it
at,
tends to average them.
Oh,
Yours
Spore.
and
one that's
Spore.
very
Spore,
successful.
yeah, we're all
The
waiting
one
for
that's
Spore.
not successful
Spore is
is
not
sitting
really
there
artificial
getting
life,
mated
it's
with.
artificial, it's
Eventually, the children
user
will
tweaked
tend towards having
procedural
more
game
successful
character.
ones.
It's an agent
Um,
sort of system, really. It's
And
like
they also
civilization.
have some,
Oh, you're tweaking
as
this
the
one.
I'm tweaking
energy
this
goes
one.
up. And whenever they meet, both parents.
They don't eat their
have
dead, do
energy
they?
for the child.
Here's the graph of population. They don't eat the dead.
Anything
No,
slowly.
and Jeffrey wants to add, like eating of the dead and physics and
Energy is used.
all kinds of things. And the thought we had was we would try to build this into a 3D scene graph and get all those affordances and then continue the development. So we're hoping that we can find people who want to work on that.
And there
Or
are
any environment,
these
throw
type
the
knowledge
creatures
or
into a
systems,
3D scene
any
graph.
calamities that
Try
happen,
fit
like
it well.
What's interesting with this one is they produce their own calamities. The survivors
Has he considered networking this game? This,
It's- That would be what the EvoGrid is about. That the
After a while,
different gene pools would send their young, very much like in Tierra, Tom Ray's Tierra, where the young were sent off to other servers. And then the servers that had more CPUs tended to have a club net type thing, and there's a lot more reproduction. And we're just talking about if you network these together, it's a lot like Tom Ray's original Tierra experiments of the early 90s, where Tierran creatures, which are just strings, are sent off to other servers and they reproduce rapidly and fill them up, and then they send the offspring are sent out. You could do that. That would be an EvoGrid type thing of connecting these gene pools into a grid. Oh yeah, look at that. We've really just increased food growth delay is low, hunger is high, energy offspring is high, food spread is low, so it's dense, and see what happens.
One neat thing you can do with this also is on the view button you can go to what is the most prolific of all the swim bots.
Okay.
This is the one that's had the most
Cool.
offspring. And it basically you see the one that is the most successful. I mean, being prolific means most evolutionarily
just about
successful.
divided.
It's dying. Actually, there's one right on top of it that's dying.
Yeah. And they turn black as they die and just
Oldest virgin.
Bruce, you were saying earlier that Jeffrey wants to open this up for development.
He does, and
What's it written in?
I think it's straight C.
Whoa.
It's written in, and you can see it's sort of platform independent, GUI. Runs on Mac and Windows.
the arrow, that white arrow on that one shows that it's wanting to mate with the other swim bot in the same direction arrow. And that one wants to mate with it, but their pattern of swimming means that they're basically
There they go.
they're in a mating dance. And
Oh,
they-
that one's
Oh,
dead.
one died.
It's black widow.
That is successful
Yeah.
mating.
They can be mated to death.
Oh,
Not a
no.
Oh,
bad
no,
way to
that's
go.
the
Usually
offspring?
not. Yeah.
Two little ones.
It made it and then
So
the
they
other one
increase their
said.
size, basically?
Oh, what's that? This guy's
when
a
they're
killer.
first born, they look like a little egg.
Right.
And
It's a
then like a
black
yolk or
widow.
something. And then within maybe 10 seconds or so,
Boy.
they cut and get to their normal
You get the
size.
cure.
This could be a new Facebook.
However, they can be mated with before they mature. So, which is kind of cruel. But
Oh,
Yeah.
no.
Need to run.
Now, one more thing before people have to go. I mentioned, this is the last bit of it. This is the open source platform that we built for NASA that is usable by anybody in this room who wants to download. It's at digitalspaces.net. I'll just show you a couple of things it does, and then we have to probably finish up this evening. So it's basically ODE physics. It's the ogre scene graph. It's all the Crazy Eddie's GUIs. Let's just try to go forward here, swing this around, and knock these blocks over. Whoops, I just missed the blocks.
There you go.
Oh, no,
Okay.
supposed to be on the moon or something?
So, well, this is one of the demo environments, but there's about 20 applications for NASA with various vehicles and multi-user, single-user. This is the playground world for developers, and everything that you see here, all of the GUI elements, the vehicles, and everything is scriptable with Python or XML or direct API calls. C++. These are cubes that you have to push through. And
what lessons do you want to learn from this?
Well, what this is for NASA. This is I should show you some of the other applications. But they use this for lunar rover design concepts for crater explorers or docking, landing, entry, descent, and landing, asteroid spacecraft to asteroids tethered down, EVAs. We're doing the shuttle mission right now for the Hubble telescope, a simulation for Hubble telescope. And so it's a general purpose platform to do anything to do with physics and rigid body dynamics. I actually should assign to vertical axis. Boom, up. Pivot left and right. It's supposed to make the excavator go up and down. No.
You do stress testing on materials with this? Or?
Well, not really to that level, but generally, think of all of these objects. These could be any of your creatures or gene pools, creatures moving around in 3D and hitting those glass cubes or hitting more fluid or striking each other or and all scriptable with Python and destroy, create objects and things like that very fast. Very, very lightweight platform. There's a lot of overhead in it.
Can you use lots of them? Lots of objects? How many?
It's actually pretty, from what we've done.
Can you use thousands?
Probably not. If you're doing full physics, contact it, not thousands. So you have to sort of scale it up. But we get very good frame rates on very, very high performance physics vehicle, multiple vehicles running around on multiple surfaces and kicking up dust and whatnot and generating clouds of particles. And so we don't really ever see a frame rate problem. We haven't pushed it that far. But an A-Life experiment will push it. But it's one offering to the community that it's a framework. It's a little bit better than just writing to OpenGL. You've got a lot more services in there, and it's not a professional game platform either. But
we have nice documentation how to use it.
Yeah, there's a whole website. If you go to digitalspace.com, click on the top link, and it goes to Digital Spaces with the plural.net, and that's got tutorials and example worlds. And there's 3 universities using it now that have adopted it for PhD projects. And there is universities. It's University of Toronto, City Tech University in New York, in Brooklyn, and University in China. And then there's a project starting up with Goddard Space Flight Center. And so our dream of making a really good open source platform for people are picking up and they're writing stuff in the forums and they're posting their applications. But it was launched on November 30th. So there's a guy in San Diego going to get the Linux port finished, because this is right now only Windows, but they're driving on the Linux port, and then there'll be OS 10 port. So that you can see there's no operating system based GUI either. It's just all this in-scene render GUIs. So that's that. And that's what I'm hoping to bring to the community for your projects. So we can use a single scene graph, and we can then put a lot of effort. You can put a lot of effort into other things than having to do all the scene graph elements and physics and stuff. It saves a lot of time. You can just focus on, your aspect of it. The Darwin's Park may end up getting rewritten in here because they already use Ogre 3D. That one with the growing plant world. They say it's trivial to put theirs in here, so you can have growing plants in here and the robotics and swimming creatures and whatever starting to interact using different capsules of internal logic but in the same scene. So the plant growth thing is here and the creature is here, and how do they interact? And does the plant eat a leaf off of the creature eats a leaf from the plant, and the plant can adapt and grow different leaves. You can do that in L systems.
Nice.
Topiary.
Nice critical mass.
Yeah, and you get a critical mass of, the network effect happening.
You can get flowers too.
It flowers too. So anyway, and I know people. I guess it's about 9 o'clock. So is that a
interesting.
good stopping point for?
How often are we going to do this?
Oh,
We'll talk more about it next time.
Jeffrey Ventrella, who couldn't be here because he works at the Internet Archive. He's offered to host it at the Internet Archive next month. So toward the endish of June, but not too close to where people are turning into pumpkins and going away on their vacations, we could have another meeting up at the Internet Archive.
Where's that?
In the Presidio in San Francisco.
Oh, cool.
It's a cool place because they've got the cool book producing machine that makes books right in front of you, and it's a neat place. So that would be for our Bay Area coverage. That would be a city location we can come to, and we have a good peninsula location. Thank you. And then we might end up having an East Bay location and really make it a Bay Area thing. But if you're not on the mailing list, you could give me your address, and I can make sure that Tom puts you on it. I know the models for this is DorkBot. Does anybody go to DorkBot meetings? It started in New York, and it's in like 50 cities now, and it's distributed. It's incredible. Its subtitle is "People Doing Weird Things with Electricity." But DorkBot's not a bad model for this. But the growing of this little baby network of clubs is just starting, so we don't quite know. It's a distributed group of people putting together all the services. Anybody here is dying to make web page updates or put it in a wiki, you're welcome to maintain our wiki. As long as you're getting announcements, or it seems to be working great on Silicon Valley.
Yeah, the old who works at Google suggested we might want to try to do a Google Talk sometime. And he would be happy to set things up for us. They do these technical talks at Google every now and then. Oblivion, which was the big game a year or two ago. But it was just a PC fantasy role-playing game. But I remember the deer. When you're outside and you're walking along, you see some deer grazing in the distance. You walk along, as you get fairly close, they'll like perk up to you and just like bound off, I mean, it was so realistic the way it was done. And they also had like wolves and stuff that sometimes you just see them run after and take down the deer. There'd be a chase. I mean, and it would always be on kind of the periphery of what you're watching. And I thought that was very impressive. I mean, I don't know if they used any kind of complex artificial life programming. It may have all been mostly pre-staged, but it really added a lot to the atmosphere of the game.
And I think we're going to see a sort of huge boom in super realistic biological worlds. And the more we can actually put some real kind of biological concepts in those worlds, the more interesting they're going to be. And yeah,
And more relevant.
Yeah.
Maybe it could be a Facebook ad.
That will carry it forward.
Yeah, you got to find some interesting way in which people can play it.
And we have to find some use for 128, 256 core processors that Intel's going to come out with no real use other than running Microsoft Word slower or something.
Right. The PlayStation 3.
And one shouldn't forget that in the NVIDIA cards, there's lots of little microcore processors. What is it? There's like 600-700 or something. It's amazing. Inside one of the projects at NASA and the Colorado School of Mines is to harness the power of the NVIDIA card as a supercomputer, because it's a connection machine, multiprocessor in there, and it's a vector machine like a Cray in one card that costs $69.
Whoa.
How to harness those
Whoa.
and really drive your simulations through that hardware.
The software Folding at Home, which is similar to Study at Home, only it's about protein folding, which they're trying to find different ways that can be used for medicine. They found a way to optimize the cell processors in the PS3 and set up for that. And very quickly, the PS3 became the platform that produced the most results And this is a distributed program or computing platform. I think, and I don't know if it's folding at home, but a similar project, they are creating, having the players actually find ways to fold the proteins themselves as a game. The idea that although the computer is able to come up with all these different permutations for folding, that the pattern matching capability of the human players might actually produce some interesting folds that would be computationally difficult for the computer to come across. And I don't know how successful that is. I've just kind of heard about that in the news. And I don't know if that would be considered artificial life in games, but it has a connection at least.
Russ Altman, who heads the SimBios at Stanford, gave a talk I heard recently at a conference here, and then he said that recently what they tried doing is they essentially did some of the SimBios simulations on running them on video processors, and I think it was like almost 2 orders of magnitudes in terms of speeding it up.
Wow. It's amazing.
Yeah, it's amazing.
Well, the concept at NASA was to basically populate a refrigerator-sized cabinet with these cards on a gigabit bus. No one's done this, and you just get an incredible supercomputer out of it for next to no money.
I think it's mostly because there's such competition between the video cards.
There's no standards.
Yeah, even compared to the CPUs. They can produce video cards at a faster rate, and there are so many, high-end game players who are constantly, wanting to get the latest, greatest card, so they're able to produce so many versions of it a year that it's just very competitive and produces very fast improvements in processing capability.
Well, the video cards are just doing a very simple operation, but lots of them really fast. So it's easier to, you don't have to have an extensive instruction set, but you have to be able to just process an array, basically a big array of data.
Like using FPGAs or something.
Anyway, there's a huge potential. I mean, our little field to dovetail into that hardware revolution and really use it, as Tom at Noble Ape has shown, that the manufacturers want to use that kind of software. So that's another grant potential, industrial type grants.
Something I'd like to point out, and I should have brought this up earlier, is what I did my dissertation on a long time ago. It's how all our machines that we live in, buildings and cars and airplanes and stuff, they're artificial life also. That a car is really an organism and becoming more like one all the time.
Becoming
Airplanes
more intelligent.
Yeah, exactly. More automated, and they have species. They evolve over time. They interact with each other. I started thinking
every year.
and I started thinking about this when I was flying back and forth to college in an airplane, looking down, and you don't see people. You just see this world, just like these worlds we saw on the screen.
ET would evolve language to come and talk to cars and.
Right.
Well, it does make you wonder
Play with them.
if alien life forms in orbit looking down on the Earth, if the telescopes would be seeing the crop patterns more than anything else, the squares and the circles and so that, and be trying to interpret life from those, visual indicators.
Might watch the farmers serving the crops.
They used to think that that's what we saw on Mars. Percival Lowell thought he saw canals and seasons. And
because particularly in the different seasons, you would see a darkness or a lightness, and it was thought that there was actual plants growing across, in different seasons.
Harvest time.
Yeah, actually the result was because of wind and frost and various different things. But with the visual capabilities of the early telescopes, they thought the patterns represented life.
We also saw canals.
And we may in the next few weeks get digging some ice.
Yeah. Very exciting. Did you guys happen to see the photo taken from the Mars Reconnaissance Orbiter of
the high-res camera?
of
falling into the
Phoenix actually coming down on his parachute?
They watched it?
I don't know if they have video of it, but they have a still shot.
Yeah,
one
they
shot,
did say
it
you could
was-
catch one picture of it.
They
though.
had to turn the spacecraft to the most oblique angle they've ever shot at pictures. The camera's actually designed to shoot pretty much straight down, but they turned it 67 degrees to catch the look through the atmosphere and the pole.
You can see the parachute strings.
Yeah, you can see the parachute
That's
in
cool.
Yeah.
you know, it's amazing on the way down.
Yeah, you see the big parachute, you see a little ball underneath the parachute,
Did you see the
and
line?
fake images of lines. I mean, they're really fuzzy lines.
You actually see the parachutes sort of translucent in one place, and you can actually see the gap. The actual shape of the parachute is
Yeah.
Wow.
it's amazing. And if it had crashed, that would have been the last picture.
Well, maybe that would have shown a sign of what had happened to it if it had crashed. If we had a shot like that of the Mars Polar Lander,
Yeah.
its predecessor, it might have given some clues.
Apparently, they cut away the parachute a few miles above the surface.
Yeah.
I didn't think that they'd do it that high, but.
So to be continued.